In this video, we are going to look at the second part of Mathematics 2021 paper 1 for external. Now this part will consist questions from 14 up to 23. Now we can begin with the first question. In the diagram below shows Mr. Mwenda's trip. He travels on a bearing of 141 degrees from A to B. He then decides to continue with his trip from B on a bearing of 255 degrees to C. The angle BCA is equal to 35 degrees. So the first step that we need to do is we need to draw vertical line on each vertex. So we need to draw. Here we have this north. Then for this one, I'll just extend. Even here, I will just extend it like this. Now, let's now look at the first question. So the first question is find the bearing of A from B. So we need to look at where this angle is located. So let's look at our B. He's here where there is 255. Then our A is here where there is 141. So the line where the bearing is coming is considered to be a vertical line. Where the bearing is going to is considered to be a slanting one. So here, what I mean is the line B. This is our B, and this is where our bearing is coming from. So it will move in a clockwise direction, attaching this point A. So that is our A from B. Now we need to look at what angle is this one. Now for us to come up with this angle, we are going to first look at the angle here. So here what we are going to do is we form a straight line, and we know that a straight line adds up to 180. So if we can subtract 141 from 180, we can get this angle. So let's do as wise. 180 degrees minus 141. So here we get 1 from 8, giving us 10. 10 minus 1 is 9. Here we have 7. 7 minus 4 is 3. 1 minus 1, that's 0. So the angle here is 39 degrees. Now from some of the rules of angles, if we have this point where we are forming a Z shape or alternate angle, the angle here is equal to this angle here. So since we have a 39, even here we have a 39 degrees. Now we can see that if we were to complete this bearing of A, if it were to touch at this position where it originated from, it would form a circle. So, and we know that a circle adds up to 360. So what we are going to do is, for us to find this angle of A from B, we need to subtract 39 from 360 degrees. So let's do that. So 360, 0 minus 9, impossible. So we get 1 from 6. 10 minus 9, that is 1. Here we have a 5. 5 minus 3 is 2. 3 minus 0, that is 3. So the answer for the first part is 321 degrees. So that is the bearing of A from B. Now let's move on to the bearing of A from C. So let's also look at where this angle is located. So A from C. So this line here, this line is our C. That is where this angle is coming from. And remember, we said that the point where the bearing is coming from is considered to be a vertical line. So this line becomes our C. So move from here. in this direction. So this is our line A. This is our line C. So we are trying to find the angle here. So let's look at what can we do for us to find this angle. So let's do math. Now we can find this angle here. If we are able to find this angle, we'll be able to find this bearing of A from C. Okay, so what are we going to do is let's find this angle here. Let's find this angle here. So for us to find this angle, we can subtract so we can just subtract 255 from 360. So let's get 360 degrees minus 255. Okay, so if we do math, 1 from 6, so 10 minus 5 is 5. Here we have a 5. 5 minus 5 is 0. Then here we have 205. Now not 205, it's 105. It's 105. So we get 105 since 3 minus 2 is 1, so we have a 105. Now this 105 is coming from here up to here. This is what 105 is. Now from this 105 we are going to subtract this 39, because the 39 is only between this line of A and this line of C. So 105 minus 39. Okay, so we can see that if we get 9 minus 5 minus 9 is impossible, so we get 1 from 10, giving us here we have a 15, then here we have a 9. So 15 minus 9 is 6. 9 minus 3 is also a 6, so 66. So what this means is the inside angle of this triangle is 60. So we can now add. So if we add 35 plus 60 plus 39 minus 180, we'll be able to find our angle. So let's do the math. So 35 plus 39 plus 60, because a triangle adds up to 180. So 5 plus 9 is 14, plus 0 is still 14, so we write 4. We keep our 1 here. Then 3 plus 3 plus 3 is 6, plus 6, that is 12, plus the one that we kept, we have 134. So this 134, let's subtract it from 180, then we get this angle here. So 180 minus 134. So 10 minus 4 is 6. Here we have a 7. 7 minus 3 is 4. So here we get our 46. Then we know that this angle and this angle must be equal to, since these two angles are alternating angles. So therefore the bearing of A from C is 46, but we use the 3-digit principle. So 0, 46. So whenever you get a 2-digit number, add a 0 at the beginning. Okay, now let's move on to question 15. The functions of f and g are defined as f of x is equal to x plus 1 and g of x is equal to 3x minus 5 divided by 2. Find f of inverse. So let's look at the first function here. So first function is f of x is equal to 2x plus 1. So the first step to find the inverse of a function, we replace f of x with y is equal to 2x plus 1. Then we are going to make letter x the subject of a formula. So first I'll just begin with 2x plus 1 is equal to y. So this is the same as y is equal to 2x plus 1. So from there we are going to shift the 1 to the other side, giving us 2x is equal to y minus 1. The sign has changed. Now from there we can divide by 2 here, even here by 2, so that if we cancel, we get now our x is equal to y minus 1 over 2x. Now we have found we have made x the subject of formula, so where there is now f of x, we substitute with this symbol for an inverse function. Then where there is y, we replace x minus 1 over 2. So this is our inverse function of f. Now for the second one, b, f of g of x, here we are trying to now find the composite. We want to combine the two functions. So we look at, so f is our main function, then the g of x must be replaced on the x of f of x. So here it's like this. So the main function is f. Then the inside function will be g of x according to the arrangement. Now the first step here, we are going to first write the function for f. So the function for f is 2x plus 1. Now the step that should be taken here is where there is x now, we substitute with the other function. So in our case, we are going to substitute with 3x minus 5 over 2 plus 1. So now instead of expanding, the easiest way we can do is we can cancel these two here. So we can cancel, giving us 3x minus 5 plus 1. Then our final answer here is 3x minus 4. So we have subtracted since we have different signs. So that is our composite function, or that is our f of g of x. Now we can now look at f of g of 4. So we are going to pretend as if the number is x. So f of g of x. So we can see that we have formed this function here. So this function is 3x minus 4. Now the value of x is, we have been given, is 4. So where there is x, we substitute with 4. So it's 4 here minus 4. So 3 multiplied by 4 is 12 minus 4. Then 12 minus 4 is 8. So this is how we can simplify a problem like this one. Now let's move on to, now to question as seen in the diagram below. A, B, C, D, and E are points on the circumference of the circle with center O. Distance DE is equal to distance AD. Angle ACB is equal to 20 degrees, and AOE is equal to 80. Find ADE. So the angle that we are solving for part A is this angle. Now we can see that the angle at the center is given, and this angle is 80. So to find this angle on the circumference, we'll use that property that the angle at the center is twice the angle on the circumference. So for us to find this angle on the circumference, we need to divide the given angle at the center by 2. So 80 divided by 2, we get our 40 here. So that is our first answer for this question. Now let's look at the question B, DAE. DAE, this angle here. Now for us to see clearly how we can come up with the answer for this part, let's try to draw the triangle ADE. So this is how this triangle is. The angle here is 40. Now we have been given these conditions. So we have our D, our A, and DE. Now these two symbols simply means the two sides are equal to each. And since the two sides are equal to each, even the angles here must be equal to each other. Now this triangle is known as an isosceles triangle. So for you to solve any of the two base angles given the isosceles triangle, you need to do this. So we are going to add the all three angles. So this angle x plus this angle x plus c angle 40 must add up to 180. Why? Because a triangle adds up to 180. So we can add x and x, these two are like terms, so giving us 2x plus c 40 is equal to 180. So if we shift our 40 to the other side, we are going to get 180 minus 40 degrees. So 2x is equal to 180 minus 40 is 140. So the value, the sum of the two base angles, these two x angles, is 140. So to find the angle for each, you just divide by 2 here, even by 2 here. So the easiest way, or the concept behind an isosceles triangle is whenever you are solving for the base angles, subtract the given angle from 180, then divide by 2. Now this is just the way of showing work, but you just have to subtract and divide by 2. Now let's move on to question C. So here we are saying this angle here is 70. So I have 70, even here is 70. Now for question C, we are looking for BAD. So BAD, let me use blue. So BAD, this angle here. Now for us to find this angle, we can find the angle here. So since we have these two triangles that are originated from A and B, the angle ACB must be equal to the angle ADB, since these are giving us angles in a same segment are equal. The point is, if we have a circle like this one, so if we have two lines, being two triangles originating from the same here, so the angle here is equal to the angle here. This is how we've come up with this 20 degrees. Now from there, we can also try to create another picture here. So from this part, we can look at this point here. So 20 plus 40, here we have a 60, then here we have a 70. So what this simply means is opposite angles in a cyclic quadrilateral adds up to 180. So this angle here must be 180 minus 70. So we can find this angle B by subtracting 180. By subtracting 70 from 180. So let's do that. So 70 from 180 is 110. So here we have this 110. Now let's look at this triangle alone. So the angle here is 110, then the angle here is 20. So we can find this angle. So just say this is x. So say x plus 20 plus 110 is equal to 180. Then we can add 20 plus 110 is 130 is equal to 180. We can collect like terms by shifting 130 to the other side. So 180 minus 130. So our x is equal to 50 degrees. So this means that here we have a 50. So our angle BAD is equal to 50 degrees. Okay, now let's move on to question 17. So question 17 is a point R, negative 3, 1 is mapped onto a point S 2 comma negative 1 by translation t, express t as a column vector. So here this arrow is, this point represents the object. So this is a transformation, but out of the 6 transformations we are looking at the translation where the object moves in a certain direction without changing the size and the shape. So this is our object, then this is our image. So now for us to find the image, the formula is like object plus translation vector is equal to image. So object, the coordinates for object are -3 and 1, plus we are solving for translation. Then for the image are 2 and -1. So we are going to move our -3 and 1 to the side, giving us t is equal to 2 -1 minus -3 1. So we can do now math. So the mathematics is, we have 2 minus -3, then on the bottom part we have -1 minus 1. So our final answer here is 2 negative multiplied by this negative, giving us +3. Then -1 minus 1 is -2. So our final answer is 2 plus 3 is 5 divided by -2. So this is our translation vector in a column vector. Now let's move on to question B. In the space below is an incomplete program written in pseudocode for calculating the mean m of the 10 numbers whose sum is s. Complete the program by filling in the blank spaces with appropriate statements. So let's look at the first question here. Enter. So we enter the input. So here our input is 10 numbers. So we don't know which numbers are these. So we just say enter 10 numbers. So it can be maybe all numbers from 1 to 10 or 11 to 20. It can be any number. We are not given. We have just told that it's a mean of 10 numbers whose sum is s. Now if we add these 10 numbers, I mean, we are getting a sum of s. So now for us to find the mean is equal to the sum of those numbers, which is s, over the number of those terms, like we can divide by 10. So this is our formula, and this is what we are going to write here. So it is s, the sum divided by the number of the numbers. Okay, so the numbers were 10, so that's why we've shown this 10 here. Okay, so now we can move on to question 17. So question 17, the first part, we have been given a variation, and this variation is a joint variation since it consists of both the directly and the inversely. Now given that y varies directly as x and inversely as the square of z, and y is equal to 10 when x is equal to 32 and z is equal to 4. So let's begin by first forming an equation. So the equation is the first letter. So the first letter is y. So this y is varying directly with x, then and inversely as the square of z. So z will carry a power 2. So the language of square simply means it has to be raised to a power 2. And the other part is the inverse part should be a fraction, but the direct one should just be written the way I've written y and x. So y is related to x as directly, but related to z as inversely. Now from there, we need to look at this equation. Let's complete this equation. Y, you introduce the equal sign. Immediately you introduce the equal sign, you write the k representing constant. Then the direct part should be multiplied by k. So x times k become xk over, so the inverse part will be on the denominator part. So this is our equation. Now let's look at the first value. The first value is a. Find the value of k, the constant of variation. So let's solve for k. So for you to solve for k, the given numbers in the first part, the equation itself, as the numbers that you have to use. So let's look at y. So our y is equal to 10. K is what we are solving for. Then our x is equal to 32. Then over our z is equal to 4. Now it's 4 times 4. Okay, so over 1. So this one will multiply with k and 32. So 1 times k is k times 32 is 32k is equal to. Now here we have 10 times 4 times 4, that is 16. So instead of multiplying 16 times 10 giving you 160, you can just leave it like this, divided by 32 over here by 32. Now what I like to do is I'm going to break 32 into two numbers. 32 is same as 2 times 16. So I can cancel my 32, giving me my k is equal to. The reason why I've written 32 as 2 and 16, I know that 16 and 16, these two will cancel, giving me 10 over 2. 2 into 10 is 5. So this is one of the ways I use to simplify questions like this. But if what works for you is maybe multiplying 10 times 16, you can go ahead. So if we had multiplied this would have given us 32 is equal to 10 times 16 is 160 over 32 over 32. Now the issue with this one, it may be difficult sometimes to divide 32 into 160, or maybe what you can do, you can start now reducing. You find a number that is common that can go into 160 and 32, so you can simplify. So here we can see that 8 is common. 8 into 16 is 2, which is 20 over 80 into 32. 8 into 32 is 4. 4 into 20 is 5. So you can also answer it like this. Okay, now let's also move on to question B. B, we are solving for the value of y when x is equal to 20 and z is equal to 5. Okay, so for this one, the equation is y is equal to kx divided by z squared. Y is equal to our k is 5, our x is 20 over our z is 5 squared, which is 5 times 5. So this is direct. So what we are going to do is we can cancel this 5 here and also this 5, leaving me with 20 over 5. 5 into 20 is 4. So the value of y is 4. Or if you want, we can just go direct. 20 times 5 is 100. 100 divided by 25 is still 4. So you can simplify it like that. Now let's look at the last part for question 18. Find the value of z when x is equal to 9 and y is equal to 5. So the equation is y is equal to kx over z squared. So the value of y is 5, k is 5 also. Then our x, our x is 9 over z squared over 1. So let's cross multiply. So 5 times z squared is 5 z squared is equal. So for this one, I'll just leave it like this, 5 and 9. I know that I can divide by 5, so this 5 will cancel. Also here, this 5 will cancel. So if we divide by 5, we have z squared is equal. 5 into 5, we get our 9. Now we are solving for z, so we can now find the square root of z squared, also the square root of here. So we can see that our final answer is z is equal plus or minus 3. So this is our final answer. So this is one of the ways you can simplify. Now let's move on to question 19. A company's working capital consists of 450 10% preference shares of 50 kwacha each and 700 ordinary shares of 10 kwacha each. After 6 months, the company declared a dividend of 5,750 kwacha. How much dividend will be paid to each ordinary shareholder? So the focus is ordinary. So these 450 shares are for those like the top shareholders. Then the ordinary were 700. So what we are going to do is we are going to add the total number of shares. So the total number of shares, so total shares will be 450 plus 700. This will give us 1,150. So from there, for us to find the dividend for for us to find the dividend for ordinary share, we'll look at the ordinary shareholders. So let's look at the ordinary shareholders. So ordinary shareholders were 700 over the total number of shares in total, which is over 1,000, over 1,150 times the total dividend. So the total dividend was 5,750. So 750 here. Okay. Now let's do math. So the first way we can do is we can cancel the 0. So we can cancel this 0 here. Also, let's cancel this 0. From there, let's look at let's find a number that is common. Okay, let's divide the. So let's just leave our 700 like this. So 5 into 115. So 5 into 11 is 2, remainder 1. 5 into 15 is 3. So 5 into 115 is 23 times what of 5 into 5? 75. So 5 into 5 is 1. 5 into 7 is 1, remainder 2. 5 into 25 is 5. So 5 into 575 is 115. Now from there we need to look at these numbers on top. So on top we have 700 and 115. Then on the numerator part we have 23. So we need to look at which number can we divide with 23. Now let's check for 23. Let's first multiply 23 times 10 is 230. Is 230. That is 23 by 10. So now what if we find half? What is half of 230? So 2 into 2 is 1, 2 into 3 is 1, remainder 1, 2 into 10 is 15. So What this simply means is if 2 times 23 times 10 is 230. 23 times 5 is 115. So what this simply means is 23 into 23 is 1. 23 into 15 is 115 is 5. Okay, so here we have now 700 times 5. Okay, so now let's multiply. So 5 times 0 is 0. 5 times 0 is 0. 5 times 7 is 35. Now this 3,500, you need to be careful here. This 3,500 is the total dividend for the 700 ordinary. So for us to find the dividend for each, we are going to divide by 700 here. You need to be careful here, so that we find now for each. So we can cancel the 2 zeros, also the 2 zeros. 7 into 35 is 5. So meaning each ordinary share order got a 5 quater. So that is how we can simplify a problem like this one. Now let's move on to question B. The ratio of the volumes of two similar solids is 63 to 27. The surface area of the smaller solid is 180 square centimeter. What is the surface area of the bigger solid? Okay, so here we have a small to a bigger. Now for the small we go with 27, then the bigger one will go with 64. Now here, whenever you are given volumes of, the ratio of the volumes, you need to find the cube root for each ratio. So you find the cube root for 64 and 27. So the cube root for 27 is 3, because 3 raised to the power 3 is 27. Then for 64 is 4. So these numbers are what we call the scale factor. So that is the first step. Find the scale factor by finding the cube root for each ratio of the volume. Then upon reaching here, we'll now go back to our question. So the question is, we are solving for surface area of the bigger solid. So where there is bigger solid here, we put x, since we are solving for this one. Then here we need to substitute the given number, which is 180. So we leave our 180 here times we cross multiply. So 3 times x is 3x. Then here we are going to get 180 times 4. So I'm sure by now you've gotten my way of simplifying questions in maths where we do not have calculators. So I don't necessarily multiply the two numbers. I like leaving them like this for simpler way. So I can divide by 3, also by 3. So it's easy for me to divide the 3 into 180. So 3 into 180, so 3 into 18 is 60 plus that 0. So 3 into 180 is 60 times 4. So 4 times 0 is 0. 4 times 6 is 24. So our area for the smaller one is 240. And we can see that this is for the bigger one is 240. It's making sense because 240 is greater than 180. Okay, now let's move on to question 20. So the diagram below shows triangle KLM, in which KL is equal to 6 centimeters, angle KLM is equal to 50 centimeters, 150 degrees, and its area is 32 squared centimeter. Calculate the length of LM. Okay, so let's first begin by indicating the distance corresponding to each angle. So this distance is L, then here we have M, then here we have a small k. So the k is representing our distance LM. So let's use the area for a non-right angle triangle formula. So the area is equal to half AB sine C, but in our case the two distances that should be used are M and K because they are making that angle 150. So M K sine the angle L. Now area is given 32 squared centimeter. So where this A we put with this one is equal to, we get our half. Distance M, the distance M is 16 centimeters. Then distance K is what we are solving for. Then sine 150. Now here we can simplify. So 32 centimeters squared is equal to 2 here is 1, 2 here is 8. So we can see that we have 8 centimeters K times what is sine 150. So from the special angles, like sine 30 is 0.5, sine 30 is 0.5. 0.5 is same as 1/2. Now the concept behind this trigonometry in paper 1 is if sine 30 is 0.5, let's subtract 30 from 180. 180 minus 30 is 150. So sine 30 is equal to the remainder, the sign of the remainder when you subtract that angle from 180. So 180 minus 30 is 150. So if sine 30 is equal to 0.5, even 150 must also add up to 0.5. Why? Because 30 plus 150 adds up to 180. That's a picture that you can do. So this is what we are going to do. So where there is the sine 30, we can put half. Sine 150 is half. So we can still reduce 32 centimeters squared is equal to 2 here is 1, 2 here is 4. 4 centimeters times K is 4 centimeters K. We divide by 4 centimeters, also here by 4 centimeters. We can cancel our final answer. K is equal to 1 centimeter will cancel with this one. 4 into 32 is 80 centimeters. So this is our final answer. Now let's move on to question B. The equation of the line A is 3x plus 2y is equal to 10. Line B is parallel to line A and passes through the point 4,6. Find the equation of line B. So the formula for the equation is y minus y is equal to m, x minus c, x1. So I've been given the pair of the coordinate 4,6. So this is our x1, this is our y1. So the work that is here is we need to find the gradient of this line A. So let's write our equation. So the equation is 3x plus 2y is equal to 10. Now, for us to find the gradient of this equation, we are going to make y the subject of formula. So this 3x will shift to the other side, giving us 2y is equal to 10 minus 3x. Okay, so we can divide by 2 here, by 2 also here, by 2. Then y is equal to 10 divided by 2 is 5 minus 3 over 2 of x. Now the gradient for this particular equation is where there is now y, you replace with the symbol for gradient m. Now the final answer, you just get the coefficient of x. So the coefficient of x is our gradient for the equation a, so it's negative 3 over 2. Now the point here is, if we have two lines, this is line A and this is line B. So the gradient of line A is equal to, it's negative 3 over 2. What is the gradient of line B? Now, since these two equations are parallel to each, their gradients will be equal. So that's a concept that you need to take note of, two lines that are parallel. So even in line B, we will have negative 3 over 2 since they are parallel to each. Okay, so now we can now proceed. Y minus c, what is our y1? Y1 is 6. Then our gradient is negative 3 over 2 x minus c. Our x1 is 4. Now, to some people, it may be difficult or it may look cumbersome for you to simplify a problem that has a fraction. So what we are going to do is, first let me create some spaces here. Okay, so it's y minus c. Okay, so for those that may find it difficult to simplify a problem that has a fraction, for you to get rid of the fraction, you need to multiply everything by the denominator, in our case by 2. So what this simply means is these two will multiply with y. So 2 times y is 2y minus, these two also multiply with 6. 2 times negative 6 is negative 12. Now, if this 2 times the negative 3 over 2, these two will cancel. What we are saying is negative 3 over 2 times x minus 4 times 2. These 2 and this will cancel, giving us negative 3 x minus 4. That is one way in which you can get rid of a fraction. For those, it may be difficult. But if maybe negative 3 over 2 times x minus 4, if that is simple for you, then you can just do it like that. Okay, so now let's continue. So 2y minus 12 is equal to this negative 3 will multiply with x, giving us negative 3x. Then the second one multiply with negative 4, giving us positive 12. Now we are going to shift our negative 12 to the other side, giving us 2y is equal to negative 3x plus 12 plus 12. 2y is equal to negative 3. 12 plus 12 is 24. So this is our answer. Or if we want, we can remove the 2. We can divide by 2 here, also by 2 here, also by 2 here. So that we can also write it as y is equal to negative 3 over 2x plus 2 into 24 is 12. So we can simplify it like this. So now let's move on to question 21. So 21 here. Write 4 inequalities that define the unshaded region R on the diagram below. So let's consider this line as the first one. Then we'll consider this the second one. Then we'll look at this as our third one. Then the fourth inequality. So let's begin by the first one. So this inequality number one, it is parallel to the x-axis, so it is only touching the y-axis. So it's y So if it is touching only one axis, you write the length of that axis. So in our case y, then it is touching or cutting the y-axis at 6, so you write 6. Now the point is we need to look at the region under consideration. So the upper is greater, then the lower is less. So from the diagram we can see that our area of interest is the lower, so we are going to use the less than symbol. We are not going to put the equal sign, I mean less than or equal, since the line is in dotted form. Now we can move on to line 2. Line 2 is cutting the x-axis at 2. So in quite number 2, it's x at 2. Then this region is greater, then the inside is less. So you can see that we want the less, but this time we are going to use less than or equal to, since the line is solid. Now we can move on to equation number 3. Now for equation number 3, it is touching the two axes. So we'll look at first where it is touching the x-axis. So where it is touching the x-axis is -2, 0. So if you are trying to get the coordinate in the x-axis, is that number, 0. So -2, 0. Then under y-axis, it is touching at 0,4. So y-axis is 0,4. So we need to find the gradient. So x1, y1, x2, y2. So let's find the slope. So the formula is y2 minus y1 over x2 minus x1. So gradient is equal to y2 is 4 minus 0, x2 is 0 minus -2. So if we simplify this, will give us 4 minus 0 is 4 over negative times this negative is +2. 0 plus 2 is 2. So our slope is equal to 2. After finding the slope, we need to now find the equation of this straight line. So the equation is y minus y1 is equal to gradient x minus x1. So y1 is 0, the slope is 2, x1 is -2. Okay, so if maybe dealing with the signs, especially negative, if that may be difficult for you, you can get the other pair where we have 0,4. So any of these pair will give us the correct answer. So we can now proceed. Y minus 0 is to y. Then let's simplify first the inside. So here we are going to get negative times -2, that is +2. From there, let's simplify. So 2 multiply with this x, giving us 2x plus 2 times 2 is 4. So we have formed the equation. Now the question is we want the inequality. So equality number 3, it's y, 2x plus 4. Okay, so from this we can see that the upper is greater, the lower is less, and we want the lower part, and the line is in solid, so we use less than or equal to. So whenever you are looking for less, lower part, or which is the less region, you use less than. If you are looking for a greater region, you use the greater than or equal. Now let's look at the last equation here. Now for this point here, in quite number 4, we can see that it is touching here, also here. So if this line is passing through this, the equation is y is equal to -x. So y is equal to -x. Now for us, we need to find the region. So on top we have greater, here we have less. So we want the greater part. Y is greater than -x. So since it is in dotted form, so this is how we can find the inequalities. Okay, now let's move on to question 22. Now for question 2 is find the integral of 3x cubed over 2 minus 5x plus 1 over x squared with respect to x. So we are trying to find the antiderivative, or we are trying to integrate. So let's write our problem. So the problem here is 3x to the power 3 over 2 minus 5x. Now, whenever you are integrating or differentiating, if the variable is on the denominator part, must be written as its negative index. So you cannot differentiate a problem when x is on the denominator, but so we are going to move our x to the top, giving us 3 over 2 x raised to the power 3 minus 5x plus, if we move x squared to the top, we are going to get negative 2. The power changes from positive to negative. Then let's now integrate. So we are now integrating. So for you to integrate is you need to add the power. So the constant, like 3 over 2, will be outside the bracket. So we are going to do this x raised to the power 3 plus 1 over whatever you do to the power, you will divide by that. So it's 3 plus 1 minus 5x. This x is raised to the power 1 is 1 plus 1 over 1 plus 1 plus 2. X. So it's x raised to the power negative 2 plus 1 over negative 2 plus 1, then plus c. So let's see how we can simplify this. So 3 over 2, x raised to the power 3 plus 1 is x to the power 4 over 4 minus, it's 5 over 1 plus 1, 2, x raised to the power 2 plus, here we have negative 2 plus 1 is x raised to the power negative 1 over negative 1 plus c. We can simplify. So 3 over 2 times the x to the power 4 over 4 is 3x to the power 4. 2 times 2, here we are going to get 8 minus 5 over 2x squared. Negative 1 into positive 1 is negative 1 x to the power 1 plus c. We are done, but the rule is you don't leave x with the negative index, so we need to move our x to the power 1 to the bottom. So final answer is 3 over 8 x raised to the power 4 minus 5 over 2 x raised to the power 2 minus 1 over x plus c. So that is our answer. Now let's move on to question B. A function y is equal to open bracket 1 plus x is equal to x minus 2. So this equation has been factorized for us. So it's y is equal to 1 plus x, then x minus 1. So the first question is sketch the graph of the function in the answer space below. So let's find the coordinates. We need to find the coordinate of the first. Let's begin by finding x. So for us to find the x, where there is y, we put 0. So 0 is equal to 1 plus x, x minus 2. Then we are going to equate each bracket to 0. So x plus 1 is equal to 0, or x minus 2 is also equal to 0. So if we move 1 here, we are going to get x is equal to 0 plus, negative 1 plus 0 is just negative 1 here. So this positive 1 will change. Then here we are going to move our negative 2 to the other side, giving us positive 2. 2 plus 0 is 2. So here we are, we can now say 1. Here we can just say 2. Then negative 1. Then negative 2. So the x-intercepts are negative 1 and 2. Now let's find the y-intercept. So for us to find the y-intercept, we need to expand our equation. So it's 1 plus x, then x plus c. It's x plus, minus 2. So here, let's now begin. So we'll begin 1 times x is just x, minus 1 times negative 2 is negative 2. Then we go x times x is x squared. Then x times negative 2 is negative 2x. So let's collect the like terms. So y is equal to, so begin with x squared, then plus x minus 2x minus 2. So y is equal to x squared. Here we get negative x minus 2. So a, b, c. Now for us to find the y-intercept, where there is x, we substitute with 0. So the point is the y-intercept, it is just the value of c. So you can just ignore the x. So the y-intercept is negative 2. So if this is negative 1, then if this is negative 2 here, this is where our curve will intersect the y-axis. Now, after we are done with indicating or finding the intercepts, let's look at the value of a. So from the question here, we can see that the value of a is positive 1. Then the value of b is negative 1. Then the value of c is negative 2. So graphs of parabola are in two forms. You may have this shape where it opens downward. This shape is known as a frown shape. Then you may have this one. This is a smile shape. Now you can also determine the type of the shape that can be formed from a given quadratic equation by just looking at the sign of the value of a. So if a is positive, you get a smile shape. If a is negative, you get a frowny shape. So in our case, a is positive, so we are going to have a smile shape. That's why we have the y-intercept on the negative part. So we can now draw our curve. So this curve will pass through. So here, like this. So that is our sketch. That's what you can do. Now, for the last part, find the minimum value of y. So for us to find the minimum value of y, we are going to find the y-coordinate of the turning point. So the formula is y is equal to 4ac minus b squared divided by 4a. So let's substitute our a is positive 1, our c is negative 2 minus our b is negative 1 squared over 4, it's positive 1. Okay, so y is equal to 4 times 1 is 4 times negative 2, that's negative 8, minus our b negative 1 squared is 1 over 4. So negative 8 minus 1 is negative 9 over 4. So this is our final answer. This is our minimum value. So whenever you are solving for minimum value, maximum value, just solve for the y-coordinate of the turning point. Now let's move on to the last question for this video. Now the diagram here shows a speed time graph of an object. It starts from rest and accelerates uniformly for 2 seconds until it reaches a speed of 10 meters per second. It moves at this constant speed for 6 seconds. Then it accelerates until it reaches a speed of 3 meters per second after 5 seconds. Finally, it rotates for the next 8 seconds until it comes to a halt. Now let's look at the first question here. The first question is find the acceleration during the first 2 seconds. So here, this is our initial, since it's where it is starting. Then this is our final velocity. So the formula, acceleration is equal to final minus initial over time taken. So the final velocity is this number, which is 10. So 10 minus the initial, it is starting from 0, is 0 over. So the time is 2. We are told in the first 2 seconds over 2. 10 minus 0 is 10 over 2. 2 into 10 is 5 meters per second squared. So that is our answer for the first part. Now for the second part, value of v, this v here, value of v, if the retardation in the last 8 seconds is 3 meters per second squared. So the retardation is this line where it is slanting downward. So this now becomes our initial. So this is our initial point. Then this is our final point. So acceleration, which is negative acceleration, is equal to final minus u over t. So we are told the retardation is 3. So for A, we put negative 3. Why? It is retardation. Then the final velocity here, since it came to a halt, the final is 0. Then the initial is now the v. You go in y-axis, it's the v over the time it took from initial to the final. We have been given it's 8 seconds. So let's simplify the upper part. So 0 minus v is negative v over 8 over 1. We can cross multiply. So 1 times negative v is negative v. Then 8 times negative 3 is negative 24. So it divided by negative, also here by negative. So v is equal to positive 24 meters per second. So this is the value of v here. So we are able to find this value of v. Now let's move on to question C. Average speed for the whole journey. So the formula for the average speed is equal to total distance over total time. Now our work is to find the total distance for this shape. So let's see. So there are so many ways in which we can expand and simplify for us to find this value. So okay, so let's extend this one up to here. So begin by finding this distance here, because we know that this is a trapezium shape. So the area, which is now distance, is equal to half a plus b times h. Half the value of a. The value of a is the upper part here. So from 2 to 13, so we find the difference. 13 minus 2 is 11, so the value of a is 11, plus c, the base is from 0 to 13, so it's just 13. Then the height is this distance from the x-axis to the value of 10, so it's 10. So 11 plus 13 is 24 times we can now reduce. 2 here is 1, 2 here is 5, so it's 24 times 5. 5 times 4 is 20, we keep the 2. 5 times 2 is 10 plus 2, 12. So the first part this one has a distance of 120. Now let's also look at, let's find the distance for this. So we can see that here we have a right angled triangle. So the formula is distance is equal to half BH. Okay, so half BH, the base is this distance here from 8 to 13. That is our base for triangle, the one I've drawn in yellow. So the difference between 13 and 8 is 5. Now the height is from this point up to this point. Now let's remember V is 24. So here we have a 24. So from 10 to 24 is 14, or 24 minus 10. So our height is 14. Then we can simplify. 2 here is 1. 2 into 14 is 7. So here we have 5 times 7, giving us 35 meters. So that is the distance for the one in yellow. Now let's also look at the distance for this one, the one I'll use purple here. So even this one is also a right angle triangle, so the formula is the same, half BH. So half, our B is from here up to there, so the difference between 21 and 13 is 8. 21 minus 13 is 8. Then our height is from here up to here, so it is 24. So we can now reduce 2 here is 2, 2 here is 4. I mean 2 into 2 is 1, 2 into 8 is 4. So we have 4 multiplied by 24. 4 times 4 is 16, 6, we keep a 1. 4 times 2 is 8, plus 1 is, sorry, this should be 96. So 4 times 2 is 8 plus 1, 96 meters. So now we can find the total distance by adding the 3 distances. So the total distance is equal to 120 plus 35 plus 96. So we have 120 plus 35 plus 96. So 0 plus 5 is 5, plus 6 11, we keep the 1. 2 plus 3 is 5, plus 9 14, plus the one that we kept is 15. So 5, we keep the 1. Then 1 plus 1 is 2. So the total distance is 251 meters over the total distance is 21. Now from there, can we divide 21 into 251 into 251? So which number is common? Which number is common? So let's reduce by 3. So 3 is common. Let's use 3. 3 into 25 is 8. 3 into 25 is 8. Remainder 1. 3 into 11. No, I'm sure 3 won't work. 3 won't work. Okay, let's say 21 times 10 is 210. 210 plus 21. 210 plus 21, 231. So we have about 12. So 12 will remainder 20 over 21 meters per second. So this is our final answer, as if we can 12 times 20 is 240. So 240 remainder, so here should be 11. Okay, so this is our final answer. So you need to keep on going through the past papers. Make sure you keep on doing that, so that you see how question comes and also how you handle questions. So I'm asking for those that have not yet subscribed, please do so. Hit the notification bell so that you receive the new videos. I usually post videos on the weekend. So that's it for this video. Thanks for watching.